All right, let's talk about something we all think we know, spreadsheets, right? We use them for budgets, for to-do lists, for basically everything. But have you ever really stopped to think about what the world is building with them? Today, we're going to explore how this totally everyday tool is secretly responsible for, well, the very infrastructure all around us, from the concrete under our feet to the bridges spanning our rivers. It all starts right here, with the most basic building block of any spreadsheet, a simple formula, equals A1 plus B1. We've all typed something just like this. You're just adding two cells together. Simple. But what if I told you that this little line of code is the direct ancestor of this? Whoa! Yeah! What you're looking at is a member stiffness matrix. A structural engineer uses this to analyze all the forces in a steel frame. We are talking about values like 47,250, all calculated with incredible precision to figure out how a building will hold up under stress. So the big question is, how on earth do we get from just adding two cells to calculating the safety of a skyscraper?
Okay, so how do we actually make that leap? Well, it all starts with learning how to truly build with formulas, moving way beyond just adding and subtracting.
So the very first thing engineers do to manage all this complexity is surprisingly simple. They make their formulas readable. Look at the left. You see a typical formula, equals B4 plus C30. Sure, it works, but what is B4? What's C30? Who knows? It's cryptic. Now look at the right. This is the professional approach. By giving cells names, the formula just becomes equals X plus N. All of a sudden, it's not just computer speak, it's readable math. This is the absolute foundation for building massive, understandable models.
The next step is realizing that Excel is so much more than a pocket calculator. It has this huge library of built-in functions. With something like VLOOKUP, an engineer can instantly find the properties of a specific type of steel in a giant table. Or they can use concatenate to combine different bits of data into a single point. And they use statistical functions like linest to analyze test results and make sure materials are up to snuff.
So you can kind of see the progression here, right? You start by mastering all those built-in functions. Then you get organized by naming your data. But for the really complex, really repetitive jobs, you take the final step. You write a custom macro.
So, what is a macro, really? Well, think of it this way. If a built-in function is a standard tool you buy from the hardware store, a macro is a custom power tool you build yourself for one very specific job. It's a little program written in a language called VBA that lives right inside your spreadsheet, and it can automate thousands of calculations with just one click.
And hey, don't let the word program freak you out. The code itself can be really straightforward. Look at this. Dim length as double. That's just the engineer telling Excel, hey, create a placeholder called length that can hold a number. And the calculation? Area equals length times width. It's just simple, logical math. A macro is really just a list of instructions, turning the spreadsheet into a custom-built engineering machine.
But here's the thing. Having a powerful tool isn't enough. The tool is only as good as the person using it. And in engineering, the standards for that person are incredibly high. They have to run a gauntlet to prove they're ready. That gauntlet is called the Fundamentals of Engineering exam, or the FE exam. You can think of it as the bar exam for engineers. It's this grueling test that covers years of education, and passing it is the first huge step to becoming a licensed professional engineer. It's all about making sure the person building that complex model has the knowledge to do it safely and ethically. And the sheer amount of stuff they need to know, it is just staggering. We're talking about everything from project scheduling and hydrology to material properties, concrete design, professional ethics, and even cost estimating. The FE exam proves an engineer can handle the huge variety of challenges the real world throws at them, and that's exactly why they need tools that are just as versatile.
Okay, so we've got the superpowered tool. We've got the highly trained professional. Let's see where the rubber meets the road, or, where the code actually becomes concrete.
This is where it all starts. This is real data from a concrete strength test. To you and me, this is just a sea of numbers. Is this concrete strong enough for a foundation? Is it consistent? It's impossible to tell just by looking at it. And this is where the magic happens. By feeding that raw data into Excel, an engineer can instantly generate a histogram. And suddenly, that mess of numbers tells a story. You can see the distribution, find the average, and check if the results are in a safe range. This isn't just making a pretty chart. This is quality control that literally keeps people safe.
Engineers use these exact skills to solve really practical problems. For instance, How much dirt do you need to move to build a road? It sounds simple, but it involves really precise calculations. And this is exactly the kind of repetitive, data-heavy problem that spreadsheets were born to solve.
And believe me, these applications are literally all around you. Remember that crazy complex matrix from the beginning? That's part of a program for analyzing truss bridges. The retaining wall holding back a hillside, the deep foundation supporting a skyscraper, even the list of every single nut and bolt for a construction project. All of these are designed and managed using these powerful custom-built spreadsheet applications. So, we've gone all the way from a single cell to a city bridge. What's the big takeaway from all this? What's the final, crucial calculation we should all be making?
While it really just comes down to this, our physical world is built as much on code and data as it is on concrete and steel. That digital model inside the spreadsheet is just as critical as the physical beam it represents. One can't exist safely without the other.
It really makes you think, doesn't it? The next time you open a simple program on your computer, just ask yourself, what hidden, world-changing power is waiting to be unlocked inside? What other everyday tools are quietly building our future? Thanks for joining me.